Researchers have recently found that beneath Mercury's surface, a thick layer of diamonds may be present, buried deep within the planet, perhaps many miles down. This discovery coincides with the upcoming close-up observation of Mercury through orbit, as space agencies prepare to gather detailed data. While considering the possibility of life existing on different planets, it is essential to understand how the environmental conditions of these planets could shape the characteristics and types of potential life. Mercury, a small planet located near the Sun, has been hiding significant secrets that are only now beginning to be uncovered. Despite its small size and extreme heat, Mercury has been deceiving us for a long time. However, technological missions are now shedding light on its strange and mysterious features. The discovery of diamonds on such a harsh planet is just the beginning, and scientists are eagerly investigating what else this planet may be hiding. With its internal structure differing from previous assumptions, Mercury raises fascinating questions about how it compares to other planets in our solar system. Astronomers and space enthusiasts alike have been fascinated by Mercury for years. As the smallest planet in our solar system, it has long kept its landscape and inner workings hidden. However, with advancements in space exploration technology, its secrets are finally starting to surface. NASA's Mariner 10 mission in 1973 began the quest to learn more about Mercury's surface, followed by the Messenger spacecraft in 2004, which continued this research. Mariner 10, which provided our first close-up images of the planet, revealed a surface filled with craters and unique ridges similar to those seen on the Moon. It also showed that Mercury's surface was rough and scarred with pits, yet it had a stronger magnetic field than expected, along with a larger-than-anticipated core. These unexpected discoveries forced scientists to rethink past assumptions about Mercury's composition. The Messenger mission, short for Mercury Surface, Space Environment, Geochemistry, and Ranging, was launched 31 years after Mariner 10. It was designed to orbit Mercury and allow scientists to study the planet in greater detail. The mission produced more than 200,000 images of the planet, offering new perspectives of Mercury's surface that had never been seen before. One of the more surprising findings was the unusually high levels of calcium and magnesium found on Mercury's darker side, sparking interest in the geological processes responsible for these elements. Another remarkable discovery was that Mercury's magnetic field was stronger in its northern regions compared to other planets, further raising questions about the planet's internal composition. Unlike Earth and most other planets, whose magnetic fields are generated by liquid iron movement in their cores, Mercury's magnetic field is controlled by a unique core structure. Mercury's surface is not only marked by craters and ridges, but also by extreme temperature fluctuations. During the day, temperatures can soar to over 800 degrees Fahrenheit (427 degrees Celsius), hot enough to melt lead, while at night, they drop to -330 degrees Fahrenheit (-201 degrees Celsius), creating drastic variations. These temperature swings are primarily caused by Mercury's extremely thin atmosphere, which does little to regulate heat or maintain stable conditions. Despite these harsh conditions, recent investigations have revealed even more astonishing features on Mercury's surface. In 2012, data from the Messenger mission provided evidence of volcanic activity, including pyroclastic deposits from explosive eruptions, contradicting previous assumptions that Mercury was geologically inactive. Moreover, in 2020, scientists discovered water ice in some of Mercury's polar craters, regions that remain in permanent shadow and stay cold enough to preserve ice, despite the planet's proximity to the Sun. This discovery led to new theories about whether Mercury could harbor extremophiles, microorganisms that thrive in extreme environments, similar to those found in the most extreme places on Earth. The most recent mission to Mercury, named Bepi-Colombo, was launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency. It is expected to arrive at Mercury in 2025. This mission aims to provide further insight into Mercury's surface composition, chemical makeup, and geological history. From its unusual magnetic field to the discovery of water ice, Mercury continues to challenge our understanding. New research is revealing even more extraordinary features. One of the most peculiar aspects of Mercury is the relationship between its day and year. Unlike most planets, where the length of a year is shorter than a day, Mercury is an exception. A full year on Mercury lasts only 88 Earth days, while a single day, one full rotation, lasts 176 Earth days. This means that Mercury's day is twice as long as its year. This oddity creates fascinating effects. If you were standing on Mercury, you would see the sun appear to grow larger, stop moving, reverse direction, and then continue on its normal path. This strange motion occurs because Mercury's rotation is too slow to keep up with its rapid orbit around the sun. Mercury's slow rotation is believed to be the result of tidal locking, a phenomenon that slows a planet's rotation over billions of years due to gravitational forces. However, unlike the Moon, Mercury is not completely tidally locked. Instead, it experiences a 3:2 spin-orbit resonance, meaning that for every 2 orbits it completes around the Sun, it rotates 3 times. This leads to extreme temperature variations, with one side of the planet facing the Sun becoming unbearably hot, while the night side remains freezing cold. These drastic temperature swings make it incredibly difficult for spacecraft to study Mercury, as they must navigate around its extreme day-night cycle and intense heat. The planet's thin exosphere, a layer of gases constantly replenished by the solar wind, atomic decay, and micrometeorite impacts, adds another layer of complexity. New research suggests that Mercury's exosphere contains more water vapor than previously thought, likely formed when hydrogen from the solar wind mixes with oxygen in Mercury's surface rocks. In 2020, scientists found that Mercury's magnetic field is the result of a unique dynamo effect occurring within a liquid metal core, rather than the conventional process seen on Earth. Despite its small size and slow rotation, Mercury's magnetic field plays a crucial role in protecting its surface from the solar wind, preventing its atmosphere from being stripped away, similar to what happened to Mars. Another intriguing feature of Mercury is the concept of hot poles, regions where the sun appears to linger overhead. These areas are among the hottest on the planet, while regions near the poles remain in permanent darkness, cold enough to preserve water ice. The fact that these shadowed craters can store ice despite Mercury's proximity to the sun raises important questions about its potential to harbor life. Some scientists speculate that these cold regions could also contain other volatile substances, such as organic compounds, preserved in the planet's coldest craters. The combination of Mercury's unusual day-night cycle and its unique spin-orbit resonance creates significant challenges for spacecraft. For instance, Bepi Colombo had to perform multiple flybys of Venus, and scientists propose that Mercury might have once rotated much faster, but gravitational interactions with the Sun and impacts from large asteroids or comets have gradually slowed its spin. These insights not only provide a deeper understanding of Mercury's history but also offer clues about the formation and evolution of other planets in our solar system. As research into Mercury continues, even more questions arise. How does the planet's core remain partially liquid despite the extreme cold? How does its unique orbit affect its surface rocks? These profound questions remind us that there is still much to learn about Mercury and its role in the solar system. Although it is the smallest planet, Mercury is filled with mysterious features that continue to captivate scientists. One of the most fascinating aspects is its unusually large core, which makes up about 85% of the planet's volume. Studies led by planetary scientist Dr. Nancy Shadow at Johns Hopkins University suggest that this enormous core may have formed due to a massive impact in Mercury's early history. According to the hit-and-run hypothesis, a large planetesimal might have collided with Mercury, stripping away its outer layers and leaving behind the iron-rich core we see today. Another puzzle is Mercury's magnetic field. Despite being small and rotating slowly, Mercury has a magnetic field that is about 1% as strong as Earth's. This was surprising for scientists, who did not expect such a field from a planet of Mercury's size and rotation speed. Further studies revealed that the magnetic field originates from a thin layer of liquid metal surrounding Mercury's solid core, challenging existing models of planetary magnetism. In 2020, researchers also discovered potassium and sodium on Mercury's surface, volatile elements that typically evaporate at high temperatures. These elements may have been delivered by comets or asteroids, suggesting that Mercury's surface evolved differently than previously thought. One of the most exciting discoveries is the presence of water ice in permanently shadowed craters near Mercury's poles. Despite its proximity to the Sun, these cold regions allow the ice to remain preserved, giving scientists a chance to explore how water may have influenced Mercury's geological processes. Additionally, organic compounds have been found in these regions, raising the possibility that Mercury could contain the building blocks of life. Despite its extreme conditions, Mercury's potential to support life is being reconsidered. The presence of water and organic molecules adds to the intrigue of this small planet, suggesting that it may not be as inhospitable as once thought. Mercury's role in the solar system is becoming increasingly fascinating as each new study provides more insights into its unusual characteristics. Scientists are continually challenged to rethink their understanding of how planets form and evolve. One crucial area of research is the study of Mercury's internal structure and magnetic field. Unlike most planets, Mercury's magnetic field is generated by a dynamo effect within its liquid core, which protects its surface and helps maintain its exosphere. The Bepi-Colombo mission, set to arrive in 2025, will continue this important research by mapping Mercury's surface and studying its magnetic field and geological history. This mission will build upon the work done by the Messenger spacecraft, which mapped the planet more extensively than any previous mission. By refining our understanding of Mercury's composition, magnetic field, and geological history, Bepi-Colombo will provide valuable insights into the early days of the solar system. The mystery surrounding Mercury's oversized metallic core, its hollow features, and the possibility of diamond-like carbon compounds could help scientists unlock the secrets of planetary formation and evolution across the solar system. Despite the many challenges posed by Mercury's extreme environment, each new discovery brings us closer to understanding this intriguing and enigmatic planet. As we continue to explore the mysteries of space, Mercury stands as a testament to the secrets that remain, offering clues not only about itself but also about the forces that shape the entire solar system. The journey to uncover these mysteries will undoubtedly lead to groundbreaking discoveries that could transform our understanding of planetary formation, the potential for life, and the history of our solar system. The study of Mercury is just the beginning. As we prepare for the next phase of exploration, new discoveries will continue to unfold, revealing the wonders hidden within this tiny yet captivating world. Each scientific breakthrough adds another layer to our understanding, not just of Mercury but of planetary science as a whole. One of the most intriguing aspects of Mercury is its oversized metallic core, which has long puzzled researchers. This massive core, which accounts for approximately 85% of the planet's volume, is unlike that of any other planet in the solar system. Many scientists believe that a colossal impact in Mercury's early history may have stripped away its outer layers, leaving behind a disproportionately large core. This theory, known as the hit-and-run hypothesis, offers a compelling explanation for Mercury's unusual composition. Despite its close proximity to the Sun and its small size, Mercury's magnetic field remains a fascinating feature. Although the planet rotates slowly, it still generates a magnetic field, something that surprised scientists when it was first detected. This field is believed to originate from a liquid metal core surrounding Mercury's solid interior. The nature of this magnetic field, which is about 1% as strong as Earth's, challenges previous models of planetary magnetism. It seems counterintuitive that such a small and slow-rotating planet could produce a magnetic field, yet its existence sheds light on the complex dynamics within Mercury's core and raises questions about the planetary formation processes that led to such an anomaly. Another captivating discovery is the presence of volatile elements such as sulfur, potassium, and sodium on Mercury's surface. These elements typically vaporize at the high temperatures found on Mercury, leading researchers to reconsider how they were deposited on the planet. It is possible that they arrived via impacts from comets or asteroids, implying that Mercury's surface may have undergone different evolutionary processes than previously thought. These findings open new avenues for understanding how the planet's surface has evolved and interacted with external forces over time. Water ice has also been found in permanently shadowed craters near Mercury's poles, regions shielded from the Sun's intense heat. Despite Mercury's extreme temperatures, these areas have remained cold enough to preserve ice. The presence of water ice on such a hot planet is not only surprising but also offers scientists an exciting opportunity to explore how water may have played a role in Mercury's past. This discovery also raises the intriguing possibility that organic molecules may be preserved alongside the ice, suggesting that Mercury could contain the essential ingredients necessary for life. While this does not necessarily imply that life exists on Mercury, it points to the planet's potential to support life in extreme conditions, much like the way extremophiles thrive in Earth's harshest environments. The continued exploration of Mercury, particularly with missions like Bepi-Colombo, will provide critical insights into the planet's magnetic field, geological history, and chemical composition. Bepi-Colombo, scheduled to arrive in 2025, is especially significant, as it will allow scientists to investigate Mercury's internal structure and magnetic field in unprecedented detail. This mission will also shed light on the planet's surface features and provide further insights into its mysterious evolution. As we continue to learn about Mercury, we are also gaining a deeper understanding of planetary formation and the unique characteristics of other celestial bodies in the solar system. Moreover, as new technologies enable more advanced exploration, our ability to study Mercury's extreme environment will only improve. Understanding how Mercury's core, magnetic field, and surface interact with solar radiation and meteorite impacts will help scientists draw parallels with other planets, including Earth. For example, comparing Mercury's exosphere, a thin layer of gases surrounding the planet, to Earth's atmosphere could provide valuable information about the processes that shape planetary atmospheres and how they evolve over time. This comparison could also lead to new insights into how Earth's atmosphere may change in the future, and whether other planets have the potential to support life. In conclusion, the exploration of Mercury is far from over. The combination of its extreme environment, complex history, and unique features makes it one of the most intriguing objects in the solar system. As new missions and research continue to expand our knowledge, Mercury is proving to be much more than just a tiny, scorching world. Its magnetic field, potential for water ice, volatile surface elements, and oversized core are just a few of the many aspects that challenge our understanding of planetary science. With the Bepi-Colombo mission and future endeavors, we can expect even more remarkable discoveries that will reshape our knowledge of the solar system's smallest planet.